So yeah, I'm Dale. I'm the one of the team leaders in the Climate Action Service at Oxfordshire County Council. Also deputy chair of the National Vegetarian Society, having been chair for a number of years. But in terms of thermal imaging, I have done thermal imaging for many years, supporting lots of community groups around the county where I live, but also across England and Wales. So yeah, fantastic to have the opportunity to share that knowledge today. And I guess really the overriding message is that I really hope by the end of this training session, you will all feel expert enough, because you will be, to be able to go out, borrow the cameras and get some really good results, which then can lead to some good impactful work, essentially. So that's the aim by the end of this training session, and we'll check in again to make sure that we're heading in the right direction and we're there by the end of it. So as a quick outline agenda, and I have to say I will try and keep to an hour, but I'm happy to stay on for any questions afterwards, no problem at all. We'll try and cover these key things. So a quick overview of project aims, introduction to thermography and thermal imaging, some actual kind of worked examples of faults that you're likely to see, and also some non-faults which can be ignored, but it's good to know about them. Some camera considerations, and then if there's any feedback, although I would invite that throughout. I can't see you all now that I've shared my screen, although I can see the chat on my phone. But yeah, I think Jess is going to keep monitoring the chat as well, so do come in. Louise, yes?
Can I just ask before we get started,
sure.
Will you be sharing the slides, or do we need to be kind of making notes?
I have to say there are extensive kind of guides and helpline. There'll be a link at the end, and I'm sure Jess will share afterwards all the information. So what I'd say is, in terms of note taking and things, no, you don't need to be scribbling down lots of things as we go along. Sit and listen, hopefully enjoy as well. Do ask questions as we go through, but yeah, you don't need to be making extensive notes and things.
Okay.
Yeah,
great.
we'll share stuff afterwards.
This is really just an opportunity for those that do have some expertise already in the group, because I know that some of you have already done some thermal imaging things. Otherwise, I'm assuming a lower level of knowledge and things. So forgive me for that. For some of you, you'll already know it, but that's fine. Hopefully, as I say, we'll all come to a common kind of understanding of how best to use the cameras to get some good results out. Right, so just a quick introduction, just to say that obviously energy use within the home is for those things, and thermography is looking at the heating aspect, or rather the heat loss from buildings when taking images from the outside. Obviously from the inside, kind of, again, where drafts are coming in, and so heat is potentially being lost, but also cold air is coming in when looking at doing surveys from the inside. And if this is a typical sort of 3-bedroom semi-detached property, completely uninsulated at the moment, there are the typical sort of areas of heat loss overall for a completely uninsulated house. And let's say it's as I say, 3-bedroom semi-detached cavity wall property. So we now install cavity wall insulation, loft insulation, tackle the drafts, replace the windows, either single to double glaze or double to triple glaze. And there are the typical resulting heat losses now, having insulated the property. So you can see there that the key areas to concentrate on really is the roof insulation, relatively cheap and easy to do, to roll out loft insulation to sort of 300 mil depth, and fairly significant savings there. Walls as well, again, there's a large surface area of heat loss there, so 35% uninsulated, reduce that down to sort of 10 to 12%. Drafts, because that is a simple DIY sort of job, and £20 spend on the property actually make a fair difference. 5 or 6% savings there. Windows, you'll notice the savings are less, and of course, it would be an expensive job to do. So yeah, considerations there, I guess, in terms of cost and such like. But there may be other benefits such as aesthetics or sound reduction if you live on a main road, etc. So really, thermal imaging is just they say a picture says 1,000 words. It's an instant, easy way of being able to show residents where to prioritise those energy efficiency improvements. I won't dwell too much more on kind of things you can do and things, because I know there's another training session for that, and there's lots of advice as well on the web pages and all the resources that Jess and the team have put together. So general project aims, the kind of focus of the project may be kind of up to you, but here's some of the likely outcomes that will result. So actual direct physical improvements and potentially measurable carbon savings resulting from that. Other more simple savings, but nevertheless will add up to make a fair difference. So certainly radiator reflective foil. I guarantee that when you go around thermal imaging, you will be able to spot the radiators under windows that haven't got radiator reflective foil behind it, and it actually makes a fair difference if you were to go back and survey that same property having been installed. Draft proofing, pipe lagging, all those sort of things. You might identify some structural or as-built faults, often referred to as the performance gap, particularly sort of thermal bridging and things. I'll explain what that term means a little later. This is a potentially really important one for you as community groups, parish councils, volunteers, champions, whatever you wish to term yourselves, by raising the community awareness, basically, of energy efficiency and the support that's on offer from yourselves, from local authority grants potentially, and things like that. So again, that's a really important one to maximise use of all of that for Suffolk. Improve thermal comfort, which also has health and well-being improvements, which shouldn't be underestimated, and obviously overall a reduction in energy bills, reduction in fuel poverty. So on to the bit that you've actually hopefully come here for, expecting. So first of all, just to say, the camera is simply converting an area of the magnetic spectrum that in terms of heat loss into a visible color palette that we can see. And it will present that in terms of sort of blues or purples, darker, colder colors, meaning you're on the colder end of the spectrum, versus sort of oranges and reds, which are, or even kind of yellows and whites, on the upper end of the spectrum. So that's essentially the role of this bit of technology, which you can borrow from Jess. So a few quick true or false. Let's see how well this works on a webinar. I normally do this with a kind of in-person audience, but do feel free to unmute and just shout out. So, okay, thermal imaging. Is it used by firefighters to effectively see through the smoke? I'll have a swig of drink while you're... Any thoughts on that?
Oh, we've got some
yes,
people
right,
in the
okay.
chat.
I can see a false and a couple of trues as well. Yes, indeed, it quite often is. Yeah, to potentially see bodies in colder areas of the house that may have been overcome by smoke, but also to identify hotspots when they have fought the fire and things, just to make sure that it doesn't reoccur. So yeah, absolutely. Electricity district network operators to guide their maintenance programs. I'll go through these a little bit faster. I'll tell you, yes, they are all true. So yes, absolutely, they will. District network operators, so the local electrical operator, will use thermal imaging camera to look at circuit boards and such like substations, also electrical connections, to see if there's any hotspots, any poor connections, so that they can tackle that before failure. Breast cancer screening, yes. The local police force to detect potential drug factories. Oh yes, definitely. If you fly a drone over, if there's any really warm properties, then that's definitely of interest. Water leaks and ingress, it can be an easy way of spotting where there's a leak. If you've got a solid concrete floor, for example, then you can thermal image it and spot the water to direct your focus of attention to dig up that bit of flooring. And finally, yes, it has in the past been used to detect swine flu at airports. So I think your camera is the FLIR Edge and Edge Pro as well. So I think the Edge sort of attaches to the inside of your mobile phone, version for Androids, version for iPhones, iOS. And the Edge Pro can be used kind of freehand, or otherwise it clips around your phone. But basically, as I've said, it's a really simple way of and a really effective way of engaging homeowners, residents, to immediately see where heat is being lost and effectively where money is being thrown away, heating the environment rather than their property. So what we're interested in with the camera is that there's many things that affect the resulting image. What we're interested in is obviously real temperature variations. What confuses the image that you get, so it's worth just being aware about, are different surface properties which will present the heat loss to the camera differently. So some materials may be losing a lot of heat but appear not to be, and some vice versa. And then finally, the other kind of annoyance is reflections from the environment. In fact, if you stand face on to a window and take a thermal image, you'll see yourself reflected in that glass. So clearly it's not that bit of the glass that's hotter than the other areas, it's simply you being reflected. So here's an example electrical connection. Now, in actual fact, you don't need a thermal imaging camera to see that central connection, because there is damage to the outer insulation on the cable there as well. But a thermal image camera certainly confirms that, yes, that cable is potentially 65 plus degrees. The white here indicates that it's gone off scale, and you can see on the right hand side the scale there. So it's at least 65 degrees on the white areas, and black means it's gone under scale, so it's less than 31.7 degrees. So let's have a look at this image. What immediately can we deduce from this, looking at the image and the scale as well? And this is actually an image that was taken by Thames Valley Police, having followed this vehicle or chased this vehicle. But yeah, any deductions from that, just to prove that immediately you are already on the path to being expert and can deduce some good stuff from here, either in the chat or if somebody wants to unmute and say.
I would say it's been driving because the tyres are hot.
Absolutely.
The engine's hot.
Yep.
And he's had the windscreen heater on as well, by the looks of it.
Yeah, absolutely. Yeah, you can see that very clear sort of typical pattern of the blowers blowing on the bottom of the windscreen and the heat rising up it. Yeah. Yeah, very good. Anything else?
There's somebody in the passenger seat.
Ooh, how can you tell that?
Is that not like a light bit, a hot hot bit in the passenger seat? Or is it a heated seat?
Ah, I
Might be a
see.
heated
Yeah,
seat.
no. I see what you're looking at. Yeah. Yeah, okay. Anything else?
Well, there does seem to be some heat inside the car.
Yeah.
Slightly warmer.
Okay, well, I think we've got most things there. So just on the point of the heat inside the car, or indeed if somebody's still in it, we don't really know. We can't see through glass. We can see, in this case, we can see the heat that's on the glass. And I think that little bit that you were referring to just behind the wing mirror there, I think that's just the side sort of blower that's blowing on the side window to keep that clear where you would look through the wing mirror. So that's an important point, that we cannot see through glass. So if you're doing thermal imaging from the outside, and I know that all your thermal imaging is essentially sort of pre-booked, pre-arranged with the homeowner. There's a lot of advantages to doing that. Some other community groups take a bit of a hybrid approach, and as they're going to their booking, they might sort of have the camera switched on and have a look around, and if they find an interesting property, in other words one that appears to be losing quite a bit of heat, they, from the public highway, they may take a few images and put a postcard through saying you have been thermally imaged, come along to this public event and see the results, whatever. In which case, that kind of opens you up to more challenge from the general public that might also be walking on the pavement. But the camera cannot see through walls, cannot sort of see a heat profile behind the wall, can't see through windows. In fact, as I say, the windows are quite the opposite. Actually, sometimes it's difficult to actually see the heat that's being lost. In this example, there's quite a significant range of temperatures, so it's showing up nicely. But otherwise, had the police officer stood directly in front of one of those windows, you'd see him reflected in it. And yeah, there's something interesting with the front tyres as well. The inside of that near side front tyre is, definitely warmer than the outside. Now, that might just be because it's closer to the engine. Obviously, the engine is a source of heat. Or it might be that the tracking is out on the vehicle and you drive that four-wheel drive for another 1,000 miles or something, and you'll find you've ripped all the tread off the inside of the tire. So again, thermal imaging, while you've borrowed your cameras, if you're coming, if you've driven a few miles, you get back home and it's cold outside, get the camera out, have a quick look, check the tracking, things like that. So there's lots of things that the camera can be used for. And the only other thing to mention is, again, looking at the scale, we can deduce that it's very cold outside. It's at least 0 degrees, if not below. So I think that is all of the key kind of things there. Oh yes, the front tyres were warmer than the rear ones as well, because as with all vehicles, as soon as you brake, weight transfers to the front of the vehicle, so most of the braking is applied to the front wheels. And this car was in a chase with Thames Valley Police and was being driven harshly, therefore. So on to some interesting settings that you could either alter or at least just be aware of with the camera. Again, you don't need to, sort of spend, you don't need to spend any time setting up the camera. In fact, it will come with a suitable color palette on there and things like that. But there are some interesting things to note, and the first one of those is this parameter called emissivity or emissivity. This is a value sort of between 0 and 1, and any different material obviously has different properties, and therefore will have a value assigned to it between 0 and 1. And essentially what this is a value of how well that material shows its true heat loss for the camera to pick up and convert to a visible palette for you to see, or not. Now, the good thing is all of these things have a relatively high emissivity value, close to 1. So, for example, stone is about 0.82, brick is 0.84. those sort of things. So when you're looking at buildings, generally you should be okay. However, these things, typically metals and shiny surfacing, not okay. They've got a value that's typically below sort of 0.2, and it's very difficult to get a true reading from them. So the only reason I'm telling you this is simply to be aware. And probably the best example out of those is aluminium. So aluminium window frames are likely to be losing a lot of heat for that resident. Aluminium is a good material for transmitting of heat. Is not a good insulating material. So if you've got aluminium window frames, they're probably losing a lot of heat. However, if you take a thermal image of them, it will probably show them to be very cold. And that's not true in reality. It's simply because of the different properties of that. Now, if you were to change the emissivity value within the camera settings to 0.17 or something for aluminium, then you'll get a much truer image of the heat loss from that. However, in the same image, if you can see some brickwork, that will show up as extremely hot and losing lots of heat. So again, I would say it's not really worth changing the camera parameters. Just be aware that the letterbox might appear extremely cold, whereas actually, if there's no letterbox brushes behind it or anything like that to stop the warm air from the inside of the property coming out, then it'll probably be quite warm, but the camera won't show it. So are there any questions on emissivity? Don't want to dwell too much, as I say, on any of these technical aspects, because you only need to be aware of them. You don't need to know all the ins and outs of it. It's absolutely fine, and the camera will generally sort itself out and give some good images. Oh, I forgot I left this example in. Again, when I do these training sessions in person, I've always got my Oxfordshire County Council mug, half of which is covered with aluminium foil. And that's the right-hand side on this image here. So if we now look at the mug with a cup of coffee in it, you can see that the aluminium foil is a very, very thin, less than a millimeter thick. So it's likely that if you feel both sides of the cup of coffee, it will be very hot, around 80 degrees in this case. However, the camera is sort of seeing the right-hand side as more like 28 degrees, and it's not true. It's just the different properties. Just looking over the top of the mug, just to prove that there's not a barrier down it or something. It's an ordinary mug, just wrapped up with aluminium foil. There is coffee throughout. So that's an example. There's a couple of other considerations as well. So this is pavement, where the local authorities put some very nice sort of pink granite feature down amongst the grey granite bricks. And you can see again on the thermal image, although this is pavement and there's no conduit or anything running down the middle of it, so we assume it's exactly the same temperature, the camera sees it as a little bit different because the pink granite is just so polished and different properties. It's clearly kind of showing in a different way. One other aspect which can affect emissivity is the angle that you take the image of. So again, here the pavement is uniform, but we sort of see that the foreground appears to be warmer than the background in the temperature. And that's important when you come to, for example, taking an image of a roof. So the best, with the exception of windows, the best angle to take your image is perpendicular to the surface that you want to take, so straight on. Whereas for a roof, you'd have to be sort of, in a hot air balloon above it to get that angle. So essentially, if you can't achieve that, you're taking it quite a flat angle, which means that the front edge of the roof closest to you would typically appear to be warmer than the apex further away. Whereas actually we might expect the opposite to be true. And actually, if heat is escaping into the loft, or there's a loft room up there or something, you'd expect heat to rise, and you'd actually expect the top of the roof, the apex, to be warmer than the eaves. Jess, did you want to?
Yeah, we just got
comment?
a question in the chat
Oh,
from Claire,
okay.
who's asked if would you consider adjusting the camera for modern zinc or lead roofs?
Again, with metal roofs, yes, I mean you could absolutely put a lower emissivity. There's emissivity tables on just do a Google or your preferred search engine search. So yes, if it's an entire roof, then you might wish to apply a suitable value like 0.18, for example, for zinc. I'm guessing, don't know it off the top of my head, but that would work quite well, I suspect. So yes, you could if there was an entire metalled roof. Sounds like you've got some very nice properties down in Suffolk. Different modes of heat transfer then. So heat, thermal energy, is typically transferred between objects when there's a temperature gradient. There's a temperature difference, so it goes from hot to cold. The modes of heat transfer: conduction, convection, and radiation. Is this particularly important? Well, yes, because you can stop, or you can certainly slow down those modes of heat transfer with insulation and such like. And this is really, from my point of view, this is what the training is all about. It's about getting some reasonable images that indicate where actions should be focused, essentially, and it's all about action for me. Is the follow-up to the effort that you're putting in, which is going to create that warm environment for those residents, lower energy bills, as I say, carbon savings, etc., etc. So I'll quickly kind of gloss over these slides, but just to say that in order to take action on those modes of heat loss, it's all about the thickness and condition of the insulation, moisture content. That's important later as well when we come to kind of talking about the optimal time for thermal imaging, and obviously the material itself. So thermal imaging can detect these variations by finding the differences in the surface temperature, and that's what we're presenting back to the homeowners. And I should say that definitely what we're aiming to do here is very much qualitative, not quantitative. So we're not so much interested in actually how much heat is being lost by that particular area of wall over any other area. It's more that it is losing more heat or not. As I say, it's all about just honing in on kind of where the problem areas are, rather than kind of making detailed measurements as to how much of a problem it is. But I mean, that can be roughly deduced. So for example, the area at the top of the house here, you can see it's a very small area. It's interesting kind of why that heat profile is there. But compared with all of this area of brickwork here, clearly you're going to be losing a lot more there. And you can spot radiators here and such like. So there's much more kind of easier areas to make a big difference on, rather than kind of absolutely measuring how much heat loss is on any particular bit. That can be done by the experts. And if there's a homeowner that's really interested, or there's some really quirky things that appear to have been shown up, obviously they've got the option of getting an expert in and doing a more quantitative survey. But just to be clear, and you should be clear with the homeowners that your role is not to have the camera set up absolutely perfectly and be able to do those really detailed surveys. But it will nevertheless give a really good idea where to focus efforts. Okay, so the three major or key reasons why heat loss will show up are those on the screen. So thermal bridging, actual air leaks, and then insulation deficiencies. So these are the three key reasons why heat loss is showing up. if it's as a result of a true fault, as opposed to, for example, a vent, or a trickle vent in the window or something, or indeed an open window. Sometimes it's difficult to spot when you're going around in the dark, but you see sort of a funny kind of pattern, and actually then when you speak to the homeowner or whatever, it's like, yeah, the window's cracked open, so well, of course it's losing heat. It's not a fault, it's an open window. But these are the three key kind of causes of faults. So let's just look at some detail in particular. So thermal bridging, first of all, and again, this is a very common one that you will no doubt see. It's usually as a result of a structural beam. So, for example, above every window, in order to support the wall above that window, there'll be a lintel or a beam over the top of the window, and that will often sit, if it's a cavity wall property, for example, the beam will often sit across the insulation barrier, so it's an easier route for heat from the inside to go and show it to the outside, or vice versa if you're looking from the inside. But you might also spot conduits. So if there's an outside tap, for example, the pipe that goes from the inside of the house to feed that outside tap, that's going across the insulation barrier and providing an easy route for that heat. The corner effect is an interesting one. What the diagram is showing there is essentially that there is a much smaller area of heating on the inside of the property, in the room, if this is the living room, for example, to heat that sort of surface area that you'll see on the outside. So it typically appears colder. I've seen it the opposite as well. I've seen corners on the outside appear warmer, and I think in that case it was a cavity wall property, and I think basically it's very difficult to get insulation, retrofitted insulation that's blown in through the holes that they drill and insert the insulation under pressure. It's very difficult for that to meet nicely in the corner, and actually quite often the inside of a corner cavity is very rough with mortar and everything else. And there might be other reasons, of course, why that's happened, but typically you'd see that an external corner would be colder. Here's an example looking from the inside. This was a new conservatory that was added to this property, and essentially where they had tied into the existing brickwork, each of those kind of brick tie points were thermal bridging. So looking from the inside, there were colder areas appearing on the thermal image that you can see there. Now, the results of this is, obviously more heat loss, so therefore higher energy costs and such like. But also you quite often see that those are the areas where you'll start to see mold, black mold growing, because there's a perfect dew point. And at some point along that temperature gradient, from being nice and warm in the rest of the room to having the optimal temperature as it gets colder and colder, where the thermal bridging is occurring, you'll get a dew point, so it'll be nice and moist, and mold will typically grow. Faster deterioration of materials will then result, so flaking of paint and wallpaper peeling off, etc. Obviously there's health implications for having black mold around, which aren't good. So secondly, an actual air leak, and as it says there, shouldn't be confused with ventilation, which is really important for both the property and the occupants of the property. So proper ventilation to remove moisture that we're breathing out and cooking and clothes drying and everything else. An exchange of air periodically is important. But when it's a cold winter's night and the heating's on, then clearly you want to be able to reduce that ventilation right down. And this is what you can't do with an air leak. So drafts and such like are there even when you don't want them to be. Lots of reasons, obviously, for air leaks, poorly fitting windows, doors, whatever it might be, infiltration due to cracks in the bricks, And I think on the next slide, I've got some photos of my friend's house where you can see the air coming in from behind the skirting board. Yeah, improperly lying insulation, which is then causing a gap, etc. Air leaks is an easier one to understand and potentially to fix as well once you've spotted where it is. So the first example for an air leak, this is actually a push button for a concealed cistern for toilet that's behind this wall. All looks fine, excusing the decor of the tiles from the 1980s. All looks fine visually, as you can see on the left, but the thermal image shows just how much air is leaking past that kind of plastic button. Yeah, fairly significant heat loss or cold air coming in just for that one device. Here's a couple of images of the skirting boards. My friend had done actually quite a good job of sealing the floorboards because this was a suspended floor, and there are products to do that. But yes, behind the skirting board, very, very cold and fairly significant reduction in indoor air temperature. And then finally, insulation deficiencies, another thing that you're very likely to see, particularly if you take an image of a gable end wall with cavity wall insulation on it, you quite often see a half moon warmer area at the top where the insulation over the years has sort of slumped and compressed and settled down. So yeah, you'll quite often see this. Again, it may be improper installation to start with of the insulation, but quite often it's because of it's degraded over time. If you've been up into your loft and the original loft insulation sort of turning to dust and things, it's not very pleasant. But basically, it's breaking down. It won't be as effective anymore. Here's an example of a Velux window, a light chute, basically, and you can see that the plaster isn't insulated behind. And depending on how good your individual screens are, you might even be able to see individual colder areas. These sort of dabs of glue or cement that's been put behind there to hold the new plasterboard in place, which is a bit of cold bridging actually, as well as being largely uninsulated throughout. So here's an interesting example from here in Oxfordshire, near where I live, whereby the house on the right-hand side had cavity wall insulation, house on the left-hand side not. Although the house on the left-hand side had invested in new windows recently instead, so there's a few differences there. This is a particularly interesting example because, firstly, of the building construction, whereby the two semi-detached properties, the party wall between them went all the way across the cavity wall to the front. So you've got a really clear distinction of heat loss between those houses. And the second interesting part of it is because the two homeowners, two neighbours, were friends and very willing to sort of collaborate on this project. So they both heated their properties for a couple of hours before we came along and took this survey. So we knew that they were both about 20 degrees. So the difference there is clear to see. The investment in the windows, far less efficient in terms of reducing the heat loss, although it has worked for the windows, but compared with the sheer area of wall and potentially the cost of cavity wall insulation, much cheaper than new windows, the property on the right hand side has made a much larger difference. Just to also draw your attention to the chimneys as well, you can see that there is heat loss, more so from the property on the right hand side. So it was definitely heated indoors. You can see from the windows as well. yes, potentially if that chimney's not used, then a chimney balloon, which is a little inflatable sort of plastic thing with a one-way valve that you put up in the chimney, inflate it, and then close the valve, and it just helps to kind of seal off for heat that's being lost. Obviously, if the chimney's in use, you can't do that. But yeah, a really good example there of the two properties, and you can see that the outdoor temperature was about 2 degrees, so nicely cold. As I'll just summarize at the end of the slides in a moment, you do need a good sort of 10-degree difference is best between the indoor temperature and the outside. So in this case, we potentially had sort of 18 degrees difference, which is very, very good. So a few further examples.
May I
Laura,
just ask something, please?
Yeah, please.
Hello, sorry. Hi, I'm Laura. Just going back to the, it's on here as well.
Yep.
We had a lot of heat coming out at the bottom of near the ground.
Mm.
And I can see that here on the right-hand picture.
Yes. Yeah.
Was that identified as well?
I think I suspect in this case that it probably had a suspended floor, so that there's a number of air bricks to make sure that it's well ventilated underneath. But yes, it is one. I think I've got a better image in a couple of slides time of that. Yeah, it's interesting how, I mean, it tends to be either where the floor is joining into the brickwork, because again, those joists will sit, firmly across the into the wall and provide a warming effect on that area of wall. So it may be to do with that. Or as I say, if it's a suspended floor, you'll often see air bricks kind of along the base of the wall to make sure that that area under the floor is well ventilated and therefore kept dry.
Yes,
but
here in Suffolk, we I often came across like a different type of brickwork or screed about half a meter up to a couple of feet. So
okay, yep.
I was wondering what that is actually, if you happen to know.
Yeah. Okay, so you'll probably see that below the scree is more heat loss than above. Definitely, I would say. Yeah, I mean, presumably the scree is just an aesthetic sort of application for those properties, but actually will be helping to insulate. If you add weight of material or insulation to a wall, then it's going to it will help. But also bear in mind that the scree itself may be will be a slightly different material, so may have a slightly different emissivity value assigned to it.
Yes.
So worth considering, but it will reduce the heat loss from that area of wall anyway. So I think it's probably true what the camera will show you. I'm assuming it will show it as colder than the unscreed area.
No, it was actually warmer.
Oh, okay, right. Interesting. I would say probably emissivity then, because I would expect that any additional layered thickness to the wall would, should have an insulating effect. Yeah, interesting one. It may also be just to say that warm air rises, so it tends to gather at the tops of rooms. You can't particularly see it on these photos. I mean, maybe it's slightly warmer here at the top than it is down here. But yeah, warm air will rise, so you tend to get kind of a bit of a heat band at the tops of rooms on both layers. Of course, the upstairs may be unheated if that's a spare room or whatever. People don't tend to heat their bedrooms as much as their living rooms. So that's something to bear in mind. But yeah, I would definitely have expected actually the screed area to appear cooler. So that's Laura, if you want to send me any images, I think my email address is on the final slide. So yeah, I'd be happy to have a look at them and just give it a bit of an opinion. And indeed,
Yes.
that goes to any group. If you're doing don't bombard me with like thousands of images, but I'm definitely happy if you've got some interesting cases that you don't quite know what's going on. I'm really happy to look at them as you progress with your projects.
Thank you very much. Yeah. So we had a.
Did you say this one showed it as well? Actually,
Yes.
this is looking at the first floor. So this is heat sort of.
Oh, yes.
This is the windows of the ground floor in this case. Yeah.
Yeah. Well, it looked like that if that was just a bungalow. So
yeah,
there's a couple of feet up. There was the heat was warmer. Had a band like that. And it was mostly on the traditional buildings in so yes, I was. Are you saying so that there was more heat emitting from there, or less heat? Sorry, I'm
on this
confusing myself.
On this one, so I would expect that the area not screed would be warmer. So it might be worth just having a look at what the material is. If it's sort of a pebble dash or something, it might be worth having a little play with the settings to just see if there's a better. But yeah, interesting that it shows warmer. As I say, I'm happy to have a look at that particular example.
I'm just wondering if anybody else found that. In our area or in their area.
Yeah, and any other experience of that from those that have done thermal imaging?
That looks to me like a horizontal beam, and the what heat there is gathering beneath it.
Yeah,
I've got similar images to those that Laura seems to be talking about. Perhaps I could send some to you as well.
Okay, Andrew. Yeah, happy to do that. Yeah, so in this image here, the main area of heat loss here is it is clearly a radiator, and actually I'm a bit zoomed in here, but what this property is, looking up at the first floor primarily, is it's a bay, and this is almost like just a plaster lat. There's actually very little construction apart from some sort of wood to support and as I say, plaster lat. There's very little material between the outside where I'm stood and the inside, and so this radiator that's clearly on underneath the window is really showing itself very clearly to the camera. This area under here, I think this is the downstairs window here. Again, it's all part of a bay that sticks out by about 2.5 foot from the main house. To give a bit more room to those rooms, and so I think this is just heat gathering at the top of the room essentially. But this clearly, something can be done about that. Probably, I mean, radiator reflective foil would make a fair difference. But in reality, because of the construction type of this particular property, really it's about either externally or internally insulating that particular area, which is more expensive. There are some builders that specifically have come up with a solution around Oxfordshire for these various house types to insulate that. But yes, internally, taking the radiator off, adjusting the radiator pipes to accommodate an extra couple of inches of phenolic foam, high density insulation, and then remounting the radiator onto the surface. And that phenolic foam is plasterboard backed as well. That's really the way to make a huge difference there. But radiator reflective foil, for the sake of sort of £15, £20 spend, I would say get that back in the first heating season. Does somebody else have their hand up? I can see.
Yeah, we've just got a question in the chat.
Okay.
From Claire. Can you see that, or should I read it out?
Right, sole plate forming a thermal bridge, or DPC. Yeah. Yeah, I mean, there's definitely some. Well, actually, surprised that you can't see the thermal bridging in terms of the structure of the bay here. But yeah, definitely radiator. Here, won't go through the whole image, but here definitely lots of thermal bridgings. You can see the beams in the construction here and all the way across. In this case, rather than having a beam or lintel only across the tops of windows and having a break where there isn't a window, it looks like the construction is beams all the way across. There is a particular house type, I can't remember the name of it, where they, again, there's a beam cutting, separating the ground floor from the first floor. And interestingly, in lots of the properties, it's cavity wall insulated on the first floor only, not the ground floor. And the original reason for that was that the boilers were installed on the ground floor and they didn't insulate around the flue. And then there's an outside door and there's a window. So there's not a lot of wall space that you could insulate, but they simply didn't insulate any of it at all. So again, it's really interesting to kind of spot those properties where it's actually well insulated for the first floor, not the ground floor, whereas the ground floor is typically heated more than the, as I say, the bedrooms and the bathrooms, things like that. You can also spot radiators under most of these windows, and potentially heat gathering at the tops of windows as well, tend to be a little bit warmer. Potentially the odd trickle vent maybe here and there, but yeah, certainly lots of thermal bridging.
It's interesting, that last picture. Most French houses are built with a reinforced concrete or a U-shaped block filled with concrete right the way around the building to lock it all together at lintel height. Yes. But it's only built on the outside wall. Okay. Yes, I mean, it's a very good point actually, Roger. These could be concrete floors. There's several floors obviously high of this property, so perhaps it's, rather than just a beam, perhaps this is actually the concrete floor again, coming all the way out into the wall. This is the corner effect that I mentioned earlier. Looking first of all from the inside on the left hand side, it's you can see that it's colder right in the corner. Now again, potentially that's because there's more heat loss in the corner. Potentially it's eddy currents that tend to miss out the corner as they circulate around the room, so you don't get as much heating directly into the corner. Number of reasons, but from the outside, a little bit warmer showing there. I suspect some of you may get better images than these, and if you're happy to share, I might even be able to update this presentation to show the effect a little bit better, but not usually a huge problem, and not normally much to do about it. If it's uninsulated cavity wall, that will help, or indeed internal, external wall insulation, etc. Loft hatch, looking from the inside, another kind of key area of interest. So looking from the landing, again, in this case, you can see lots of cold air coming in. Fair temperature difference, down from sort of 24 degrees to 18.5 degrees. So yeah, fairly significant there. Some brush draft proofing or squidgy foam draft proofing around where the loft hatch drops into, and indeed making sure that the top of the loft hatch itself is insulated. The professionals tend to do kind of cheap and cheerful, staple some plastic round and fill it with a bit of loft insulation. It's actually quite effective, but you can buy, there used to be a product called Hatch Thatch. I don't know whether they're still in business, but that was good because it was both insulating the top of the loft hatch and providing a sort of draft proofing material to seal around the edge. Right, aware of time, I've only got a few minutes left, but as I say, hopefully if you've got questions, hopefully you can stay on as I can. So just a few quick last examples. This extension, conservatory with a dwarf wall, looks perfect finish from the outside. You would
hopefully happily pay the builder for a job well done. In this case, the thermal image shows something amiss with the end of that dwarf wall. Again, a bit of silicone sealing, bit of caulking from the inside made a big difference here to the homeowner, but you simply wouldn't know that there was an issue without the thermal imaging camera. In this case, for this looking at the roof, you need a thermal imaging camera. This is the dew in morning, because you can thermal image at night or in early morning, just not when there's an effect from solar gain. But in this case, you can see that there's various patches on the roof in the digital image on the left-hand side where that moisture is evaporated, and sure enough, when we thermal image, we can see some particular heat loss there. Also, the chimney is in use by the look of it. Lots of things going on here. Open window is sort of up here. We found one of the windows, sort of all the seal was draped off it. I think that's this one over here. This is a block of flats. This is the stairwell, actually largely unheated. So most of the heat that's gathered, and certainly gathered at the top of the stairwell, has come from all the flat doors that join onto it. Yeah, lots of things. Even a broken double glazed window up here, and various thermal bridging, which is part of the construction of the building. Again, would only really be tackled by some pretty significant intervention by externally insulating or internally insulating that building. So a few quick patterns that aren't faults. Here we're simply looking at a radiator, and here's the thermal pattern on the wall above that radiator. Radiators are quite interesting to look at with the thermal imaging camera as well, because you can see if there's sludge in the bottom. If the bottom of the radiator is, you'd expect it to be a bit colder anyway, because again, the warmer water tends to go to the top of the radiator. But if it's definitely colder at the bottom, then probably sludge. If it's not very hot at the top, then perhaps it's gathered some air in there. So yeah, radiators, good to pass the camera over and have a look. I mentioned earlier, open window is not a fault, but yeah, it might get you head scratching until you spot that it's open. Here, there's a few interesting things going on. There's three, I think these are thermal hot water heating panels actually, rather than electricity generating PV. And this one here appears to be warmer, but upon inspection, it was simply a reflection of the chimney in that panel, so that was fine. Equally here, there's a nice double gouge with a half moon window over it. The right-hand panel appears to be damaged or whatever. If we change the angle and get more flat onto that double gouge, you can see no, it was reflecting something. Interesting how warm that gouge appears to be anyway. That might be of interest to the local constabulary. Yeah, could be cars recently been parked in there, haven't been driven, nice and hot, or tumble dryers running away or something like that.
Could I interrupt on that? On that picture and the previous one, you've
Yes.
got a hot spot along the base of the wall. And
Yes.
that's certainly what I was going to show you photos of. Maybe
Right.
it was the same with Laura.
Yes, again, yes, this was the image I was thinking of, actually, where the heat loss right from the base. So I think in this case, a solid floor probably, and this is simply providing a conduit for the floor, which is warmer than the rest of the wall to show itself. But it is interesting. I wonder even whether it's, I mean, you wouldn't expect it in a gouge necessarily, but underfloor heating can certainly kind of overheat the a floor and then give that profile somewhere. Yes, if you email me, I think somewhere I've got a nice image of a kitchen with underfloor heating and the room next to it not, and you can clearly see the difference from the outside, just of a band of, yeah, just like this. Really hot, warmer brickwork, essentially. So I must finish now, but few just quick things to note generally when getting the optimal time for thermal imaging. Solar gain will make a big difference, particularly from external surveying. So it's good to go at least a couple of hours after the sun's gone down. Even the winter sun, obviously shallow angle across the earth, will still make a big difference. Wet surfaces as well. If there's an area of wall that's wet and an area that's not, you'll see a temperature difference there, simply because of the moisture. And obviously it goes without saying, look after these valuable cameras. So if it's actually raining, yeah, that's not good to be going out thermal imaging, unless it's just an indoor survey only. Temperature difference, at least to 10 degrees is advisable. So I know that your kind of pre-booked appointments, part of the advice to the homeowner is to put their heating systems on for a few hours before, at least get the house up to temperature 18 to 20 degrees, ideal. I've mentioned glass and window frames. Yeah, practicality and safety. There is a risk assessment worked example on the internet site. So yeah, teams of at least 2 is ideal. Also, that helps because you can have one person kind of making notes that image was, you know, of that particular part of the wall. Perhaps there was a vent there or something. So it's useful to have somebody making a few notes there and then, if you're following up with the homeowner afterwards, or if you're simply speaking with them. It's also useful to have one person who's kind of leading on the interaction with the homeowner while the thermographer can concentrate on making sure that the images are correct. If you were to consider all of those things, then you might not be able to do all that much thermal imaging in the UK, but nevertheless, yeah, as I've said, be aware of temperature differences. Wind, the wind will strip the heat away from the outside of the building faster if it's windier. And also if you've got sheltered areas, therefore you might expect them to appear warmer because the wind is not stripping that heat away and it's gathering in those areas. So something to be aware of, although, you know, you can go thermal imaging when it's windier than 3 meters per second, but and there you go. The best moment for inspection at night, I would suggest, although early morning is possible, at least a couple of hours after sunset. No rain in the last 24 hours. Good luck with that over the winter. Yeah, just if you are thermal imaging with some interesting atmospheric conditions, make a note of it, because that's useful. So I'll stop there. These, Jess, as I say, has put together a whole load of resources. So actually from that left-hand QR code, it leads you to the pages that the right-hand QR code will lead to. So if you want to scan that while it's on screen so that you've got it as a tab open on your phone. But Jess will obviously circulate the links anyway. So
yeah, they've all been sent out.
Perfect. Oh, perfect. Okay. In that case, I will go to the final slide, which has got my email address on as well. And yeah, if there's any questions.
Thanks, Dale. That was great. We've just got one question in the chat already from Claire, who's asked, as a rough guide, how much time would you allow per property for a survey?
Yeah, I think about 20 minutes is the general advice. I would say, yeah, 20 plus minutes. I would say 20 minutes is probably on the bottom end, because you'll find that there's a lot of interest in this from householders and things. So yeah, I think the website kind of advises that if you've borrowed 2 cameras for your group, then you should be able to do kind of, you know, a good, what's that, 12 surveys or something. I think it actually says 20 on the website, which is sounds optimistic. It's a 2-hour period. It is a 2-hour
yeah,
period,
I think we were saying if you've got 4 volunteers, so two teams going out over a 2-hour evening. But yeah, I guess see how it goes really, and depending how chatty the householder is as well.
Exactly. You'll as I say, it is a really popular and great way to engage generally with with residents in your area. And indeed, if you've got other projects, as I say, it's just a great way of kind of interacting and raising awareness of all the fantastic things that you're doing.
Got another question from Sonia. You've got your hand up.
Thank you.
Yep, please unmute.
One of the main things that we're doing is looking at our village hall, which is old Victorian, and I'm guessing a single skin brick. So I'm expecting it to be pretty poor. We are wondering about putting some internal, like plasterboard. But what you said about the fixing might become a bridge. I'm just wondering how effective that would be.
Yeah, there's different fixings to use. So there's some sort of high tensile nylon wall plugs, essentially, which thermal bridge far less than if you use a typical metal screw, and plastic wall plugs. So when you buy the or when you're investigating the high density phenolic foam backed plasterboard, it'll probably say, oh, you might also need these, and there are special fixings. But I would say, Sonia, think about the area that you're covering. The fixings in comparison with the vast coverage that you'll achieve, really will be lost in the noise. So I wouldn't worry too much about it. The main difference you'll make to the old village hall is just getting some of those big areas of wall covered. It's, I mean, again, sorry, go on.
Sorry. They're big windows as well, so that's going to be a problem.
Yes, the window's problematic, and if it's in a conservation zone or anything like that, or simply just from a cost point of view, you might find that secondary glazing, so putting an extra skin on the inside, is probably the thing to consider there, as opposed to upgrading those windows. Again, I mean, if you've got if you tell me the village hall, or send some digital images and things, I'm happy to advise a little bit more than that. If you were a little bit closer to Oxfordshire, I'd love to visit as well, but images might have to suffice for the time being. But I'm sure there's things that can be done. The other aspect, obviously, is the source of heating as well, and particularly with village halls. If you find kind of old convector heaters or storage heaters or whatever, better controls for those, so that it's warm for when there's a booking, but not all the time, and not overly heating. A lot of village halls kind of, the temperature gets up to sort of 24 degrees, far hotter than anybody wants it, and then they're throwing open the doors and windows, and it's just a lack of proper controls on the heating.
We're hoping to get some new heating, but by showing these images, that might help to get some grants. We're hoping that's the way it'll work, to persuade grant funding.
Excellent point, Sonia. Yes, these thermal imaging and such like can provide ammunition for improvements and attracting additional grants and such like. Absolutely.
Thank you very much.
Any other queries? Just having a look at the no more questions in the chat. I think let's just take that down, then I can actually see you again. Oh, the QR. Yes, I can indeed. Hold on one moment. The slides won't go back. There we go. Some really good resources there, in terms of kind of hints and tips to tell a homeowner. As I say, there's the risk assessment, and there's a bit of information about grants as well. I think you've put up there, Jess. So,
funding to help signpost the householders too, if they do need some more extensive work done, places they can get grants from and things like that.
And also a quick help guide for the cameras itself. One thing I've just thought that I didn't mention, which I meant to when there's a bullet point about sort of the scale on the camera, also the color palette. So color palette, you can play about with that, but really there's one called I think Rainbow, another one called Lava, or something like that. Those are the two that I would stick with. Don't bother with the grayscale one. It's and the various other ones. They don't show the temperature differences as well. And it's also good to just pick the scale that works, pick the color palette that works, stick with it, because that's easier then to compare images, and you'll get used to the temperatures that are represented there. Now for the scale, it's really important to keep a very close eye on the scale that's represented the right hand side of the images and on the camera screen, because sometimes these cameras have a quirk that if they see a little bit of sky, so if you're taking from the outside, the side of the building and things, if there's a little bit of sky that it suddenly sees, it says, oh, right, okay, I'll adjust the temperature scale to the pixel temperatures that I can see in the viewfinder, and that sky there is -40, which typically these FLIR cameras is the bottom end of the scale, which then means that the house looks like it's on fire, like everything that you're interested in, the bit of the scale that you're interested in is squashed into about 1 millimeter at the top of the scale, and the whole image is pointless, because it will show the home very hot in comparison with the depth of space. So it's very annoying that it does that. So either make sure that make sure that's not happening, or I believe you can fix the scale on the cameras. So have a look at the camera instructions. If it's starting to become a problem, I mean, often you just need to just move the camera slightly so that you're cutting out the sky. But if you're trying to take the loft, for example, the roof, heat loss from the roof, then it can be very difficult to not get a portion of the sky in. And sometimes the camera just, as I say, defaults to its extreme end and is not helpful.
Yeah, there's you can make this scale fixed to make sure that doesn't happen. But like you say, just don't include the sky if you can help it. And
the other advantage actually of fixing the scale again is comparison. So if you're taking, maybe half a dozen pictures of the external of the house, if you fix the scale at something reasonable, so if the ground temperature is 5 degrees, and the inside of the house is at least 15 degrees, therefore, hopefully more, then you can fix the scale, take all of the images, and then even when you move to around the side, or the homeowner invites you into the back garden, whatever, it's easy comparison, because actually without that you might find that the rear of the house looks worse than the front, whereas actually with the fixed scale you'll see that no, it's a cooler temperature overall, but it's just that the camera has chosen a different scale. Was that Laura? Lara had a question, I think.
Yes, hello there. Oh,
yep.
Hello.
Hi.
If we have a moment, I don't know what timing, if we've got to finish soon, or
no,
we
I'm okay, although I know others have to drop off.
Really quick question. So I've got what I was talking about on my screen. May I share my screen?
Sure.
I'm not able to from here.
You're not allowed. you don't have the permissions. Sorry. I don't know whether you can be invited to share screen, or it's because this is set up in present of you. Yeah,
you can, if you.
We might have to pick it up afterwards.
Okay, no worries. I can see lots of people are leaving. I thought we were going until 7:30, so but
yeah,
no worries. Well,
hang on,
thank you so much.
Made you a presenter now, Lara, so you should be able to.
Okay.
There you go.
Share screen. Present. It's not coming up.
Oh, maybe it didn't work. You're down as a presenter, but maybe there's another control on that.
Oh, here we go. It's picking up.
Is there an option to share the whole screen?
There we go.
Oh, yeah,
can you see it? Yes, can you see it?
Yeah.
Mm-hmm. So yeah, 1/2 meter up. It's got this. You can see the brickwork on the left.
Yeah.
That's
So
quite
what's
typical.
okay? So what are we looking at? What was that bar over the brickwork? That's sort of half a metre up, before the scree. Is that a conduit or something? That's.
I have to admit this was from last year, so my memories.
But yeah, anyway, clearly, it's so this is showing. So there's no scale on this, but presumably the kind of yellower colours are warmer than the screed area, which is what I would expect. That's what I was saying, that the scree area should be, adding a degree of insulation over it, and where the scree isn't around the window as well, that's warmer, as you'd expect, and you can clearly see the lintel above the window as well, which is a bit of cold bridging, but it's structural support for the rest of the house. So
I think that yes, the yellows and oranges are the warmer sections, aren't they?
Yeah.
So we were wondering why it would look, why the heat is that. Yeah.
So I think
could that be because the house is built on a slope and the damp-proof course is therefore higher, being on the downward side of the slope? And that in fact is.
No, it wasn't on a hill, Roger.
Okay.
But good thought. Thank you. No, it was like this all the way around the house.
Yeah, I see the spot temperatures there now as well. So, which is another setting on the camera that you can ask the camera on the images to pick out the coldest pixel and the warmest pixel, which obviously you've got on here. So that can be helpful as well. So yeah, the rest of the house walls kind of hovering around 9 degrees, and we've got 12 and a half.
So with that colour there being warmer. Have I got it right that is heat emitting from the wall lower down, or is that right? Not right?
Well, so I would guess that if this property didn't have that scree starting half a metre up or whatever, I would guess.
Oh, sorry, it's below the brickwork is. Yeah,
the brickwork's below, and then there's an added scree starting half a metre up. Yeah. From below the window and all the way around the window, because we can see the brickwork pattern on the lower part of the wall. So I would suspect that if this property hadn't been screed at all, that you would see the whole of that wall being similar to kind of 12.5 degrees thereabouts. And I think that the scree itself is helping to insulate and therefore helping to prevent the. Sorry, are we looking from the inside or the outside? I'm assuming
this is
outside.
The outside.
Yeah. Right, fine. Okay, so what I'm saying is hopefully correct. So yeah, in the absence of the scree, I would expect that the whole of the house wall would have been that sort of yellowy colour at 12.5, 13 degrees thereabouts, and the screed area is helping to prevent the heat loss showing itself to the camera on the outside, and it's helping to keep the heat in the wall, essentially. Does that make sense? Because where the scree isn't at the bottom of the wall and kind of immediately around the window, you can see that it's warmer. So it is losing more heat, definitely. As I say, emissivity is always different material properties is always something to bear in mind. But I would say in this case, the screed area of the wall is thicker than the bare brick. And therefore the bare brick is less insulated, and we can see the effects of that. It's warmer.
Yes, right, okay. Yeah,
so
I think it appears thicker in that part of the wall.
Where the brick
but
is.
I'm not sort of very familiar with this construction.
Yeah. The scree is added to the surface of the property, is that right? On top of the brickwork? If you've got any
Yeah, if you've got any digital images of that property, then that might help determine. But I assume that the brick is the base construction, if you like, for the property, and then it's been screed from there upwards.
Right. Okay. Yeah.
So it's cooler, I would guess. But yeah, interesting what that plain bit is over the just above the red 12.5 degree pixel dot.
Yes.
As I say, whether that's doesn't actually appear to be making very much difference to heat loss, but it's just interesting what it is. And yeah, quite often, if you're going around at night, that's why it's really useful to have the homeowner there as well, because they can say, oh yes, that spot of heat up on the wall there, that's the vent from the bathroom, or whatever, or vent from the boiler.
So the advice. So we were wondering whether the advice should be to externally insulate that section below. Put an extra screed on.
Bearing in mind kind of moisture considerations against the ground, or rain bouncing up off the ground onto the wall. I assume that's why the bottom bit is left. Just so that it doesn't sort of draw the moisture up and cause damp problems on the wall. So yeah, but again, I mean, at least the reassuring thing here is that, well, actually, relatively, most of the area is, heat loss has been reduced as a result of the scree. Whether there's something maybe on the inside that can be easily done without kind of, inside is always difficult because obviously there's decoration and skirting boards, picture rail higher up and whatever. But yeah, I think perhaps it's done because of moisture and such like, and that's why it's been left. But relatively, it's a smaller area. Hopefully, in this property's case from last year, hopefully there were more easier things to tackle that were highlighted elsewhere on the property.
Great.
But yeah, no, it's an interesting one. Yeah.
Yes. Okay. Thank you very, very much for that. It's interesting. Stop sharing my screen now. Okay.
Anybody else with any queries? No? Okay. Well, thank you very, very much. As I say, dale.hoyland@btinternet.com or through Jess. If you've got some interesting quirks or whatever, we'd love to see them. And otherwise, good luck with the projects, and certainly keep in touch and feedback on. Again, there's a survey form for this on the website I've spotted to feedback on the number of properties that you've done and the types of properties and all of this sort of thing. But yeah, huge thanks from Jess as well, I'm sure, for all the fantastic efforts that you're putting in, because it really is, we're very, very grateful. And all the resulting actions that result in things will collectively add up to make a significant difference.
Yeah, totally. Thank you, Dale, as well, for the session. It's been really useful, I hope,
welcome.
for everyone. Great. Should we end it there then?
It's been recorded, so feel free to share and hopefully get more interest as you go on, and you might well find as well that homeowners, as a result of doing some actions and things, might ask if you're doing surveying next year as well. Get you back and see the difference, which is always nice to do.
Great.
Okay.
Thank you, everyone.
Yep. Thank you very much.
Oh, hang on.
Thank you. I have actually sent you a couple of photos, so I will be interested to hear
Thanks,
your
Andrew.
reply. Thank you very much. Great meeting. Thank you.
Thanks, everyone.
Cheers. Thanks all.
Thank you.
Bye.
Cheerio for now.
Thank you.
Bye.